The next question down on the assignment is dealing with a freight train. Now, freight trains are massive, as you know, trains are huge, and that's why they always have to blow their horns when they come to an intersection, because they need whoever is there to get out of the way, because they cannot stop very quickly, and they also cannot start very quickly. So this train has a mass of 3.0 times 10 to the 7 kilograms. And if the locomotive or the engine can exert a constant pull of 4.7 times 10 to the 5 newtons, which is a huge force on a huge mass, it's asking how long will it take to increase the speed of the train from rest, so 0 meters per second, to 81 kilometers per hour. And we're going to disregard friction here, which makes the question a lot easier. So I'm going to set this one up, and then we can go through it. So first thing I'm going to do is write down all my information. So my mass here is 3.0 times 10 to the 7 kilograms, which is the unit that I want it in. My force is in newtons, 4.7 times 10 to the 5 newtons. My initial velocity I know is 0. My final velocity is in kilometers per hour, which is not what I want. I want it in meters per second, because newtons is assuming meters per second, and most of our calculations we always want in meters per second. So I'll figure that out in a second. And what I'm looking for is my change in time, or how long is this going to take. So that's a question mark. Now, a little trick, whenever you're going from kilometers per hour, kilometers per hour to meters per second, you can simply divide by 3.6, because there's 3,600 seconds in an hour and there's 1,000 meters in a kilometer. So that's I went over that in a previous video, but if I do that, 81.8 divided by 3.6, I'll get 22.72. So this is equal to 22.72 meters per second. Okay. So now I need to think a little bit. How can I figure out the time? Well, there's two equations that I know of that deal with acceleration, time, force, and speed. The first one here is force is equal to mass times acceleration. Now I know my force and I know my mass, so I can figure out acceleration. And if I was to divide this side by mass and this side by mass, this would give me acceleration would be force divided by mass, and I'm going to use that in a little bit. The other one is I know that acceleration is equal to the change in velocity over the change in time. Now, if I knew my acceleration, I'd know change in velocity, I could find my change in time here. Now, I'll have to do some algebra to figure out what my change in time would be equal to. So if I do that, I have delta t times acceleration is equal to change in velocity. And then if I divide both sides by acceleration here, I'll get change in time is equal to my change in velocity over my acceleration. So now I just need to figure these things out. So back to here, my acceleration is going to be 4.7 times 10 to the 5 newtons divided by 3.0 times 10 to the 7 kilograms. And I'll get an answer in meters per second squared here. Now I'll squeeze it in down here. My acceleration is going to be 0.0157 meters per second squared. Now we're dealing with a huge force, but an even huger mass. So this makes sense for a train acceleration. They get going incredibly slowly, so about 0.015 meters per second squared. That sounds about right. Now I'm going to take that number and plug it into this equation. So my change in time here is going to be my change in velocity. So my change in time here is going to be my change in velocity, which is just my final velocity, 22.72 meters per second. divided by 0.0157 meters per second squared. And you'll notice meters per second cancels with meters per second. I'm just left with seconds in the end. So my change in time here is going to be 1,450 seconds. Now I could change that into minutes or hours if I needed, but I do believe the question asks me to answer in seconds. So 1,450 is what I'm going to want to do. So let's plunk that in here. 1,450. And there you go.